Lesson 15 also is a 3D analysis, and here I'm gonna do some extrude command and something that I tried to do in lesson 13, but because the addition of my ANSYS reached the limit of number of elements that I have or I can have in my simulation, I couldn't finish it. So today what I'm gonna do is a simulation of something like this. Go this line, and then I hope I can make a good 3D drawing in here. And then this is going to be a circle or an arc. And then right in this concentric with this arc, I'm going to have another circle, which is going to be um, subtracted from the entire model. The thickness of this model is going to be 1 millimeters or 1 millimeter. This length is going to be 50 millimeters, and this one also up to here is going to be 50 millimeters. This length I'm going to give 40 millimeters. The radius of this arc is going to be 25 millimeters or 20 millimeters. And I'm going to give a radius of let's say 10 millimeters to this interior circle. The material is going to be steel again, so elasticity is 200 gigapascals and Poisson's ratio is 0.3, and I'm gonna fix this end from here. So this back is gonna be fixed, and then let's apply a pressure on this area, assuming that this is hanging from the wall and something is hanging from this region. And let's say this pressure is 1000 newtons that I'm going to apply in there. But since I'm going to do a 3D model and the addition of my ANSYS is limited, and I tried this with some fine meshing, but it failed. So the meshing that I'm going to use for this analysis is going to be very coarse. It's not going to be proper and appropriate for this modeling, but this is just a demonstration on how you can do this with ANSYS. I'm going to also again use extrude command along line, which is something like sweep commands and SolidWorks or CATIA or Pro-A or softwares like that. So let's go to ANSYS and do the analysis. Okay, in ANSYS the first thing is I'm going to come to here to preferences and click structural, and then go to post-processor or pre-processor, element type, add edit, and add a solid. And then since I'm going to do a 3D analysis, I want to pick solid 187. The options, I'm going to stick with the defaults. I don't need to define real constants, so I just jump to materials and then pick structural, linear, elastic, isotropic, 200 gigapascals for elasticity and zero 0.3 for Poisson's ratio. Then I can go to modeling, but before that I want to turn on my 3D or ISO modeling or view. I'm going to create some key points in here in active CS, which is a global Cartesian. The first one is going to be at, all of them are going to be at the x of 0. The first one is going to be at y of 20 and z of 0.5. Apply, and then the other one is going to go to the y of minus 20, which give me a length of 40 in here. Now if I pick z of minus 0.5, this gives me the thickness of 1, apply. So these four key points 1, 2, 3, 4, are the ones that I'm going to use to draw the area or the rectangle. And then I'm going to use or define key point at the center, apply, and then go in the X direction for 49 points, apply, and then remember this is key point number 6. Go 1 point or 1 millimeters in Z direction, and then now make this one 50, apply, 6, 7, and 8. Remember these numbers, and then go 50 in Z direction. Okay. Oh, sorry, I have to delete the last key point that I just made. Key point number 10. Okay. The reason I made these key points 6, 7, and 8 is that I'm going to make an arc in here and kind of have sort of a fillet or a round corner for this 3D model that I will make. Let's get back to create. I want to create lines, and first I'm going to create straight lines. Instead of picking key points, I'm going to give the numbers of key points. So let's start with key points 1 and 2, apply. Key points 2 and 3, apply. Key points 3 and 4, apply. And key points 4 and 1, apply. So these lines are made for me that I'm gonna use to make the rectangle. Then I'm gonna use key point 5 at the center to key point 6, apply, and then key point 8, which is here, to key point 9. So 8 and 9, 8 and 9. Okay. Now I'm going to use key points 6, 8, and 7 to make an arc in this area. So I'm coming to arcs by end key points and radius. For the end key points are key points 6 and 8, so I'm going to pick 6 and 8, click OK. And then for the center, I'm going to click or pick key point number 7. OK. The radius of this arc is 1. I click OK. So the arc is made for me in here. If I zoom in, and I guess the lines are going to disappear if I zoom. But if I plot lines, you will see that I have this arc in here. Zoom back, and I have everything. Now I want to go to areas, arbitrary by lines, and I pick these 4 lines and click OK. So I have this area and these 3 lines. Let's get back to here, operate, extrude, areas along lines. I'm going to pick this area only, and then 1, 2, 3 lines. And my area or my volume is made. I have 3 volumes. If I come to here, 1, 2, 3 volumes that I have. Let's try to add them together before going further. So booleans, add volumes. Now I have only 1 volume left. Volume number 4 left. Now let's get back to create. Let's make a volume, a cylinder by dimensions. The radius is going to be 20, and it's going to made at the center x0 and y0. But my z is going to go from minus 0.5 to plus 0.5. Click OK. So I have this left, or this made. And if I get back to list volumes, I have 2 volumes, volume number 1 and volume number 4. Now I want to add these 2 volumes together. Come to operate, add volumes, this and this, click OK, and again I will only have 1 volume, which is volume number 2. Let's make another volume, another cylinder, same location, the same Z's, but only from on a radius of 10. Click OK. So this one is made. Now again, I'm going to go to Operate, Booleans. Instead of add, I'm going to subtract volumes. This is the first one. Okay. And then the cylinder. Okay. Now plot my volumes. And this is my model. So the model is ready to be meshed, and as I said in the introduction of this lesson, I'm going to use very coarse meshing, and for that I'm going to come to manual size, pick lines, and all lines divide them by 3. This is not at all a good practice in meshing, but because this version of ANSYS I'm using is limited, I have to stick to some restraints. Come to volume, free, pick this, click OK, and hope that I won't reach the limit. Oh, I didn't. But as you see, this is very coarse and improper meshing for this model. But if you have access to a better version of ANSYS, just go ahead and make a finer mesh, especially around here that you're gonna see more deformation and stress. Okay, let's go to loads, analysis type, static, define loads and apply structural displacement on areas. I'm going to pick this area now. Click OK. All DOF be 0. So this end is going to be fixed. Now let's apply pressure on areas. Not that one. Okay, this one. Let's apply a pressure of 1000 there. Click OK. And let's solve this problem. Current LS. The warning or the error that I'm getting in here is because of coarse meshing that I made. It's telling me that probably this analysis is not going to be accurate, but since I know that doing finer meshing is not possible for me because of this software I'm using, I'm just going to click yes, and solution is done. Now let's see how this model deforms based on the loadings that I did. So this white line is the original shape and it's going downwards in y direction. So counterplot, go to DOF, y direction. This is how it deforms. Well, we're not expecting deformation in this face. So it's between 0.35 times 10 to the minus 10 to minus 0.25 times 10 to the minus 6, which is 0 is in this range. But let's see the vector form of the translation. See, we have nothing in this face, but everything is in here. Total displacement. Okay, this is the way we see here. Then also we can go and find the stresses. Let's say von Mises stress. This is how everything moves or changes. Let's try to rotate that thing a little bit. So here we're having a little bit of stress concentration. This face is not really facing any stresses or high stresses, but we have stress concentration in this corner. Let's get back to this form. List results, and let's see the reaction solution, all items. So the loads for all the nodes that are on this face are given to me. Now for another practice, let's remove that load or pressure that I applied. Let's plot elements. Let's get back to define loads, delete structural pressure on areas. Okay, so this load is deleted. Now let's apply another pressure on areas, but instead of picking that, let's pick these areas. They're both on the same face. Let me just watch from front. Let's cancel this and do again. Okay, seems it's not easy to pick the areas. Let's go this view. Okay. They're not the same areas that were on the same face. So the other thing I want to do is come to here, plot controls, numberings, and areas, and plot volume. So area number 11, let me zoom. Okay. See if I can pick 11 and if that one is 17. Okay, I found them. Okay, this was delete. Alright, I have to come to app, apply, areas 17 and 11. Okay, now the same load I'm going to apply, click OK. Now let's solve this one. Yes, solution is done. Now let's see how my model deforms based on this loading condition. Let's look from top. So this one is going that way in the Z direction, and let's see deformation in Z direction. So again, nothing in here, and then it starts to move that way. Let's see this. And also, let's see the total displacement. Basically the same. And we can also go to list results and see reaction solution. Okay, so again the loads for all the nodes in this face which we fixed are given to me. And see nodal loads. Well, this is gonna give me the loads for all the nodes, but we know that if I came to list or select entities and then pick some nodes. For example, let's come to select entities. First I'm going to pick lines and click apply and pick this. Okay, only these no lines. Click OK and then select entities, nodes attached to lines all. Click OK. Now let's go back to nodal results, forces again. So only the loads on those nodes are given to me that I can see in here. Select everything. And well, yes, this is what I was gonna show you today in this lesson. So I used extrude along lines, so I just made a rectangle in here and extrude that along this line, these three lines, with some fillet in here. Fixed this end and applied some pressure on these faces, and we saw the deformation of these of this model. And the rest of the things are what we do for every analysis. We come to list results and plot results and get the results that we want. Also, we can define path and map onto path the results we're looking for, and then uh, just plot them on graph. I've done them in previous lessons, so you can refer to them. And this is the conclusion to lesson 15.